Hello again, and this time to exercise number 4 for Exercism and Scala. In this exercise, we're looking at Anagram. This again will probably be quite a short video because Anagram is quite simple. An anagram is where two words are anagrams if we can use all of their letters in each of the two words. So tan and ant, for example, are anagrams, as we can see here. You have to use every single letter as well. So we can't say ants and tan is an anagram because tan is missing an S compared with ants. There's a few things that we have to think about in this one, and one of them is how do you approach it. The way I approached it is I just did exactly the same thing as the previous exercise, so that's why I think that this video should be quite straightforward. The idea is you basically map each word to the map in exactly the same way that we did it in word count, and then we just compare whether they match. We just iterate through each one, and you just write a predicate to check whether a single case is true, and then iterate through that, and then apply a filter over the predicate. And then that's it. That's basically how you do this particular exercise. So let's start. Class anagram. Excellent. Well, we're looking for a word. It's of type string, and then that's our class. The first thing we should probably do is change this word into a count of the letters. So let's just call it letter count, because why not? And what do? We notice if we look here, because I'm skipping ahead and cheating, is that we only return identical words. Well, we return unique words. So in this instance where you have corn, we don't return corn again, and there's another one which doesn't return the same words over and over again. But yeah, you get the idea. So we'll start off by standardizing everything. We'll just make it to lowercase, why not? And then we group by. Again, we can group by every single letter because, well, why not? That's how you would do this question. No, I don't think there's any other way to do it. And we group by identity because we're just looking at every single letter. And we just use map values by length. And then we have the mapping for the letter count. So then, how do we match a single case? Let's just do that first. So let's define single match. Let's say word 1. How boring. String. What do we want to match with a single match? We want Boolean, of course, right? Yes or no, true or false. Remember, we want to eventually do something like, who knows, list of words dot filter by single match underscore. That's all we want to do. Something like that. With that in mind, how do we do that? So firstly, we just map this word to exactly the same thing that we just did. That's probably not the best way to do it, but it works. And then what do we have to do? We just have to check that this one is the same as that one, and then we're all happy. So firstly, as we can see here, in the corn example, we don't want to match them if they're exactly the same, and we want to standardize and match it or whatever. So what cannot be true is word cannot equal to word 1. So word cannot equal to word 1. Right. If they are equal, then obviously that's false. But what's more, we have to make sure the cases are the same. So let's just cast everything into lowercase. Stuck in an AND condition, because obviously that's not enough. And then if that is true, then we just have to check that the mappings are equal. Then we can just do that by, well, checking the mappings are equal. And once that is done, that is it. We have our predicate, which will return a Boolean, true or false. So lastly, we just need to define matches, which is over somewhere here. Sorted, matches, whatever. Matches, there we go. So define matches, and we have a list of words. Let's call it word list. And what is it? It's a sequence, right? As we can see over there, and it's a sequence of what? Strings. And what does it return? We can see as well, it returns a sequence of strings. What did I put in S? String. Excellent. How does it work? Well, we defined a predicate already for a single word, so let's just use it for filtering things on everything that we've already done, as I just showed underneath. And that's it. That should solve the whole problem. Now, if I said, now if the word I'm thinking of isn't predicate, well, tough luck. I'll just pronounce it wrong the whole video. So let's just check whether it passed everything, which it has to have, because this example is ridiculously easy and very simple to do in Scala. That's the beauty of Scala. Come on. The waiting part is always the worst part. Did I miss a semicolon, a parentheses, maybe a comma, or added a space which I wasn't meant to? Hey look, it passed 10 out of 10, and there we have it. There's the answer to Anagram, Exercism in Scala.